Hi everybody, I hope you guys enjoyed your weekend. I've been enjoying the Minecraft. And as I did say, we are moving away from Minecraft this week. We've had a lot of really positive response to Minecraft. I think people are really enjoying it. So I hope you guys are continuing to play around with it, learn more about that. We also will hopefully be going back to it a bit, incorporating some of the new stuff we were talking about, and I'll talk about that a little bit more today. So that won't be the last you see of Python and Minecraft, just like how we ended Python but then ended up going back to it. Maybe we'll return back to SketchUp as well. It's just nice to be able to incorporate these things that we're learning further in the semester. But today we are going to have a bit of change of pace, and we are going to learn about ancient engineering before the times of Raspberry Pi and computers, way back there. So kind of how today is going to go. It's going to be a bit of history in the beginning, exploring different cultures, and then about halfway through, you guys are going to get the opportunity to think about some of the design options that people had to problems and strategies people had to consider when they were building and engineering back before the Common Era, and then consider some engineering problems and challenges that people face today, and we're going to kind of compare those. But that will be a hands-on activity of some games for you guys to play. So just know, sit through the lecture and you guys will have more of a hands-on activity. Elizabeth, I do have the Wednesday webinar posted. It should have been posted straight to Edmodo. Let me see. I can check that. I was trying to check that right now, but I'm not logged in. I posted it Wednesday night along with a previous one. All right. I can double check that. All right. Let's go ahead and get started today. So the first kind of civilization that we're going to be talking about are the Romans. And you guys may have talked a bit about some of this stuff before. You may have seen, talk about the dome or the aqueduct. The Romans are a really popular group that is studied in history class. They did so much for engineering. But what's really important to consider is that the Romans didn't actually invent most of these things that you see here. And we'll talk about it more when we go into the individual ones, but the Romans didn't invent the arch. They didn't invent roads, those kind of formed naturally as humans took the same paths. But they perfected them. So they took things, water, power, the different technologies that go into that, and they took them and they advanced them. And what was really fascinating, especially when it comes to their architecture, is that they had a very rudimentary knowledge of math. Very rudimentary. And so they weren't able to calculate things like stress and weight. So the way they built these incredible buildings were through models and experimentation. And everything that they built had to be very sturdy. That's why a lot of the buildings that they have today are still standing. Things, and we'll talk about this more as we continue, things just really are not made the same way today as they were back then. These things were made to withstand so much, especially the roads, just no comparison at all. So we're going to kind of go through these. So pontoon bridges. These are a well-known military engineering feat, and this is popularly studied. You see here the pontoon bridges seem to be made of boats, and there are stories of kind of people being able to march across rivers on their boats. But what an actual pontoon bridge is this structure that allows you to cross a river without diverting the river. So you're actually able to kind of cross that body of water without having to move the river, and without having to spend the time to build over the river in an arch, or as we'll see later, these semi-arch, segmental arch bridges that they would make. So these bridges, they had to be built very, very quickly because they were mainly used with military, and so they had to be guarded, and they were used to kind of like advance troops. So if at all possible, the enemy would try to prevent you crossing the bridge. And the great engineering feat with pontoon bridges is that engineers realized that they could ram the beams in at an angle against the current. And so the current would actually end up forcing the beams further into the ground, which would create these really extra strong foundations. And then these beams would be lashed together and a wooden bridge would be built on top. And it says Caesar's bridge that he created, a pontoon bridge, it's very famous, to cross the Rhine River, which was thought to be impossible, only took 10 days to build. And I mean, part of this, there's no real way. This is just from accounts. That's kind of the story or the myth about it. It's hard to say whether or not these are true, except that different sources, they take different sources and try to see how accountable they are, depending on other stories those sources have told or other accounts that they have told. But it said that he was able to create the Rhine River is incredibly strong current and very wide, and is able to build a bridge across it in 10 days to cross that. All right, another engineering feat that they perfected, they did not create the arch. So arches, when they were created, they are perfect circles. An arch is a semicircle. It's a perfect semicircle. And so if you guys have ever, sometimes in kind of museums, they'll have, I know at Discovery Place they have an exhibit where you can practice building an arch using bricks, and that semicircle shape gives support on all sides, and it's very strong, so it can support a lot of weight. What the Romans figured out that you could do is that you could actually have several arches together rather than one perfect semicircle, and they were able to use this. This is the segmental arch, kind of how it's designed as a structure. Here, this is the Alcantara bridge, and you can kind of see these are really those perfect semicircles, but you could see them also more like this. You'll see them in buildings as well as in bridges, and they provided support. They were able to carry a lot of weight. Again, remember, Romans weren't able to calculate how much weight these angles would be able to construct using math like we would be able to now. They had very rudimentary concepts of math. So they did use some with engineering, but a lot of it was models. And a lot of it, they just had to make sure to build these buildings extra strong, these bridges incredibly strong, and that's why they're still around today. Using multiple segmental arches allowed them to build longer bridges and less material required, so that if the water actually had to flow through the arches, it could flow more easily, lessening the strain on the bridge. All right, and then they took the idea of the arch and they kind of brought it into 3 dimensions. They rotated it in 3 dimensions. And you guys can kind of think of that if you had that arch shape in Google SketchUp and you really almost use like the follow me tool, right, in a circle, you can kind of see in your mind, try to picture that from 2D, a flat arch, and kind of making it into that dome. And they could use these domes to create a more roomy interior space which was an impossibility before. They had these heavy stone roofs in buildings, and so their buildings would be really impressive from the outside, but dark and uncomfortable on the inside. And this is something that we really take for granted. If you guys, granted now, if you guys think about kind of the beautiful buildings that we have, I don't know if you guys have ever been to Washington D.C., but we have all of those domed buildings, and you'll see them all over the world. A lot of churches will have them, just and a lot of government buildings or older buildings will have those domes. It creates this really lovely interior space that we are able to get now through things like vaulted ceilings as well. But at the time before this architecture, adding that dome shape to the top of a building, it would just be a flat stone roof. And they were able to do this with the invention of concrete, which we'll get to later. They were also able to utilize water power, and Vitruvius, you may hear that name. He was called the godfather of Roman engineering, and he was able to kind of combine Greek technologies like a toothed gear and the water wheel itself, and he was able to create more advanced technology. For example, the water wheel used to only work for falling water, like a waterfall. You would have to kind of either create a waterfall by diverting water or place your water wheel there. They were able to instead use flowing water, and they could utilize that. And this is an example of kind of engineering and technology coming about because of a need. And I'm going to take a moment, jump out of here, make sure we don't have any questions. And I'm going to pose a question to you guys because I know you've been listening a lot. Why do you guys think there would be a need? So water power, what water power could be used for would be to grain, or what it was used for often was to ground grain, to take wheat and grind it into more of a powder so that it could be used to make bread. So why do you think it was important that they had this ability to grind much faster? Why do you think they needed a way to do that in Rome during this time? You guys might not know too much about Rome, but what kind of was happening? Yeah, Jeremy. Jeremy says because Rome was large. That's true. As Rome grew more and more powerful and successful, there was this idea of coming in to the city and living in the city. Cities became more and more populated. And this was across the board, not just in Rome. But they needed a way to feed the people as opposed to people being on their own separate land and kind of making their own food. As they moved more in cities, there was that idea of more processed food. So this wouldn't actually be considered processed food by today's standards, but the idea of having to grind grain for many, many people to make bread for many people. And then Austin says to supply their armies, and that's true as well. As the population grew, they just needed the ability to feed more people. And we're going to see this theme throughout. As they need to be able to do things for the larger population, engineering is a response to that. And we definitely see that with the aqueduct. The aqueduct is a very, very impressive. So this is an example of an aqueduct that's still standing today. You can see the multiple arched there. So how the aqueduct worked, one thing about Rome that we'll learn about is that they were not too great to the water source that was right next to the city. And this was true about many different cities at the time. As soon as they grew too large, the water source would become very polluted. They wouldn't be able to get their water from that source. So you can see this here. This is kind of how the aqueduct worked. This is how any aqueduct worked. It's called the aqueduct, is known to be this network of underground pipes and above ground water lines that would channel water into the city from the countryside. And Rome is just very famous for having a very large one. When it was first constructed, which was around 300, BCE. And just to make sure you guys understand that, you guys may have heard the term BC and AD. I'm using the terms BC, A, and CA. And those stand for before the Common Era and the Common Era, as opposed to BC and AD, which are just not as used as much anymore. But if you guys, it's the same time period. So before the Common Era, 300 so 300 BC or BCA is when they first started creating these. And it was, again, keep in mind, they were doing this based off of models and experience, testing it out. They did not have the math to figure out, okay, if the water is moving this quickly, how am I able to get it through this valley? What they would do is create these siphons. They would get the water going so fast down here, like imagine like a roller coaster. It's going, they would make it dip so far down and move so fast that it would be able to rise up out of the valley. So this is if they were creating these tunnels for the water to get to the city and they experienced a valley like this, they would have to dig the tunnel down really steep. This is the landscape, right? Dig this tunnel down really deep in order to get it up this valley. And they did have these inspection shafts. I mean, these were really advanced tunnels for water. Again, I cannot emphasize enough, it was 300 BCA, or BCE, pardon me, a very, very long time ago. And they had these bridges if the valley was too low to be able to get that water across. Siphons were very expensive to make and difficult. It was actually less expensive to make an entire bridge. So very cool. This is how they got water to the city. And you can see here, sewers are an example of kind of an accidental invention. Initially, sewers were used to divert water from marshes, but into the city. When the aqueduct kind of was created, they were able to use those channels that they already had to divert those marshes in order to take sewage out of the city. And these eventually, you could see, this would be an example on the street, kind of had these covered alleyways that would take sewage to kind of like larger drains, larger channels. And they were really important because they prevented disease and kind of removed that unpleasant sights. Again, this is an example of technology as response, because more and more people were moving into the city and it became a huge necessity, because before that everyone else just threw all of their waste out the window onto the street. It really was getting out of control. Very unhealthy to do that, to live in human sewage. And heated floors. This is also an example. They had to find a way to heat their homes without an open flame. Who here can take a guess why they did not, why heating with fire would be a bad, might lead to some problems? Why did they want to avoid every person in Rome firing? Yes, Elizabeth, you are right. And Samuel as well. Yeah. So, and Jeremy, thanks guys for responding. What Samuel had, especially, the houses were made of wood. There were a lot of parts of the city that were either not completely made of wood, but partially. So fires were a huge problem. Instead of, yeah, Olivia as well. It's to prevent a fire in the city, and if a fire started, it would spread very rapidly. It was they had systems to kind of prevent or maintain, but they were a huge danger, especially as population was growing so rapidly. So what they created, this would be what was under the floor. All of these columns are under the floor, so this would be the floor and the wall of the home, and then under it would be these columns that, or this space supported by columns, and there'd be a furnace in one room again, under the floor. People would have no access to this. You can see that there. That would pump all of this hot air under the floor. And then tiles, called wall flues, these hollow tiles would kind of, the air would move up into them and heat the house that way. It was much safer than just using the open flame. All right, roads. So roads were incredibly important. And as who pointed this out earlier? Austin pointed out, Rome had huge armies. They are very known for that. And they, in response, it's a way to be able to kind of check on their expansion and have their armies move swiftly on land. They created this incredibly expensive and extensive span of roads. By 200 Common Era, CE or AD, there were more than 53,000 miles of major highways. And if you see how these roads were created, this is like a cross section. So you wouldn't walk, from left to right here. You'd be standing here and either moving forward or backwards. It's like a slice of the road. And how they would construct it is they would dig a ditch first, then fill that ditch with large stones and sand, pebbles and gravel, and then have these paving stones. So once they digged the ditch, I believe that's just the side. I don't believe they had actual paving stones on the side as well. But they would dig a drainage ditch, a slightly more shallow ditch next to it as well. And many of these roads are not only still around today, but actually still used today. These were very, very impressive. Building a road this way, especially with the technology they have, takes a very long time. But it works very well. This is much more stable than an asphalt road would be today. Concrete. Concrete may not seem that impressive, especially as we have all of our buildings made out of steel and other seemingly more impressive substances today, but concrete was revolutionary. It's lighter and stronger than regular stone. And again, just take a moment to think about that. Not only is concrete lighter than stone, but it is stronger than stone. So as a building material, there was no comparison. It was easier. You could use rubble, lime, sand, and volcanic ash. And that's what they used to create concrete. And it could be poured into any form. They would create these wooden molds, and that's how they made a dome, actually. They'd create a wooden mold, and then you could just pour in the concrete. It was cheap, much cheaper than having an entirely stone building, and fireproof. It could set underwater. It was flexible enough to survive earthquakes. Some structures, not all structures, but it was very, very impressive. And actually, this building that we saw earlier, the Pantheon, is still to this day the largest unreinforced concrete structure in the world, and it has existed for 2,000 years. And this is the Pantheon today, made completely of concrete. So concrete definitely changed the building game. All right, and we're going to leave the last thing we're going to talk about with the Romans was siege warfare. This is a very popular subject to be taught in schools because it's really cool. They, again, they didn't create siege warfare. They perfected it. And it was technology as a response as people's castles and architecture got better, as they were able to reinforce their structures more. There needed to be weapons that responded to that. So they had the ballista, which is like a giant crossbow. And then they also had the onager, or the onager, which is not as well known, but it was less accurate but more powerful. It's more similar to what you might see with a catapult. But all right, do we have any questions? Yes, Sam, it's a lot of roads. Someone was just commenting on. It was a very impressive establishment of roads in a short amount of time. All right, so now we're going to talk a little bit about engineering from the Islamic Golden Age. And this is a time period that many of you guys know as the Dark Ages. And it was called the Dark Ages because in medieval Europe, when it was happening, not a lot was going on. There was a lot of war, people were very poor, and there was a lot of violence. And whenever there's a lot of violence and strife and struggle, art and science kind of takes the back seat. That's the general trend. But we can look over here, kind of in this area, and it has starts kind of here and expands outwards. A lot was happening, just so much, and I cannot emphasize this enough, guys. The Islamic Golden Age, the Abbasid Empire, Abbasids, a very cool time period. I know today we're just kind of focusing on the technology and the engineering that came out of the time, but so much came out of here that is really important, and then a lot of time doesn't get spent on it in class. And to be truthful, we spent most of our time on the Romans because a lot is there about the Romans and what they did, and it's really easy to kind of lay out what engineering feats that they kind of created or perfected. But it did take a little bit more digging to get a shorter list. So we're going to spend a little bit less time on the Islamic Golden Age, but I hope you guys get really interested in it. And just before we start, really quickly too, I wanted to point out that here the term Islamic, the Islamic Golden Age refers to an Abbasid, which was a group, an Abbasid historical period beginning in the mid-8th century, lasting until 1258. And this is a time when the Arab world became a center for intellectual pursuits, and they became champions of knowledge. Knowledge was really treasured. They would have these centers of knowledge at these schools where scholars from around the world would come. It would be free if you were able to kind of get your way into it, if you were smart enough or able, came from the right family. And I want you guys just to remember that this here, in this use, this is a political term as opposed to a religious one. And it's used because many ethnic groups and or peoples kind of fall under its umbrella, since the Abbasids expanded rapidly but did not force all of their conquered lands to cede their traditions and cultures. So a lot of their culture is kind of derived from their religion, but not necessarily all of it. So I don't want you guys to necessarily tie all of these ideas together too much, but it is what the name of the age is called. And it describes this whole section of the map. All right. So enough about that kind of political term, or this political term. So what did we get during the Islamic Golden Age? Huge mathematical advancement. Algebra, trigonometry, irrational numbers, induction, frequency analysis. This was all created during this time. So this revolutionized engineering. Now they could do things like figure out the weight, especially with trigonometry. That used a lot of geometry. Very, very important. Trigonometry today, foundation of how bridges are constructed. And they also created the concept of the number 0 on the number line, which is very cool. Here's some examples of the great Mosque of Kairouan. And it was founded in 670, though it's present form is largely from the 9th century, and you can kind of just see the different architecture style there. I will do my best to pronounce these terms. Apologize for that, guys. This is the Bab al-Barkia Gate. And what was really cool, so this dates back to the 12th century, and it was part of this wall. It was a fortified gate that had interlocking volumes, if you can see this here. So a computer went back. This is the actual wall, and they created a scan and kind of a reconstruction of how it fit together. But this would be the gate here, and it had these interlocking volumes that surrounded an entryway, so right here, in such a way to provide really kind of incredible security and control. So you'd still be able to easily open and close the gate, and people would be able to get in and out. But the interlocking kind of aspect of this gate, in the way it was constructed, gave great control on who could leave and enter the city. And kind of just the last thing that we're going to talk about during this time was Abbas ibn Firnas. And just another point here, guys. Abbas is a really common Islamic name, and Ibn means son of. So you might see these a lot later in school. And just to explain that, so this is Abbas, son of Firnas, or Abbas ibn Firnas. He is known as the first person to attempt flight with a heavier than air glider, and this is kind of a little reconstruction. You can see a lot of little pictures like this, or sketches like this, of his glider. This was in 875 Common Era in Islamic Spain. And many gliders after him were designed based on his designs. And as we know, that's a huge part of engineering today, so very cool. All right, and then just, again, really briefly, just a few more advances in Asia. I really wish I had time to go across the world and kind of show some really cool advances from all across the world. But for today, we have the Great Wall of China, which had been known for a very long time as being the only man-made structure able to see from space. Now, as our cameras and our satellites get better, we can actually see many man-made structures from space. It's difficult to see. You can kind of see it there. If you follow my mouse, I don't know if you guys can see it very well. And it's difficult to see because the materials they used are very similar to the ground. But it was built over a very long period, so people kind of have this concept that the Great Wall of China is one thing, but actually the first and most famous was built between 220 and 206 BCA by the first emperor of China, Qin Shi Huang, and the majority of that wall was actually destroyed. The majority of the existing wall was constructed during the Ming Dynasty, and currently the wall stands about 5,500 miles long. So if you guys can just try to imagine, and imagine with the roads as well, with the Romans, they were not able to go up here and take a look at the landscape. Maps were not as specific as maps now today are, or not as accurate, I guess I'd like to say. And so it took a great deal of planning and engineering to be able to create this wall that would hopefully at one point connect to the next part of the wall that they were building. And same with the roads, especially because the roads really did have to connect. They were being built at different points. Out of China is known for their 4 great inventions, which are the compass, gunpowder, paper, and printmaking. But kind of compass and gunpowder here. Gunpowder, obviously the mother of modern firearms and weaponry. Now, this is an example of an accidental invention. They were kind of mixing medicines together and they got an explosion, and then they went into building firecrackers, and then like the ancestors of guns. And then here is the compass, which absolutely revolutionized sea travel. Before then, it was a lot of cartography and studying the stars that you'd be able to navigate on a ship. But the compass, they created this free-moving magnetic needle installed on a fixed axis, and from that point, we're able to navigate accurately on a ship. All right, and then the banao, I'm going to apologize if I'm mispronouncing that. Rice terraces of these were created in the Philippines, largely by hand, and I think these are just absolutely gorgeous. I would love to see these one day in person. These were created by hand, and they are 2,000 to 6,000 year old man-made structures carved into the mountains, and they are still used today. 2,000 to 6,000 years old, and they are still used today. And they are used to grow rice mainly, and it's a very sustainable form of agriculture. It's man and nature working very well together, which is why it survived for so long. But absolutely gorgeous. All right, that's the last today. Let me see if we have any questions. I see a few people have actually been joining during this lecture, and thank you guys for your patience as we kind of went through that history of, I wouldn't call it a history as much as just a sampling of some of the different things that were coming out during the early Common Era, or even before the Common Era. Does anyone have any questions? All right. So I want you guys to be thinking when you're looking at all of these really impressive structures, it's hard to even appreciate them when you have all of this technology that surrounds you. It's hard to appreciate, and I'm saying this on my term as well, it's hard for me to appreciate how impressive these structures are, and how technology has been changing this design process. So this is the engineering design process that is recognized, and we went over this before. Identify the problem, kind of identify criteria and constraints, brainstorm, generate ideas, explore possibilities, select an approach, build a model or prototype, refine the design. And I'm not sure it goes necessarily in a circle. I don't think you have to identify a new problem. Maybe refine the design is a step that I feel like is a circle all in of itself. But this is kind of the basic idea of how we go about today. But I wanted to take kind of the second half of class, or the time that we have left, to think about how this design process is different now than it was when they were building something like the Great Pyramids of Giza, which are the only of the 7 wonders of the ancient world still visible today. 2 million blocks of stone, averaging more than 2 tons each, created this, and it's actually difficult for me to tell from this picture. I believe this is one of the pyramids is much bigger than the others, but perspective might be skewing this here. See if I get a better picture of this. Maybe they are not as... Oh, here we go. All right, so what I was thinking of, they're actually the Great Pyramids of Giza. There are 3 Great Pyramids, and then also these 3 smaller ones for the queens of the pharaoh. 2 million blocks of stone, and the first finished around 2580 before the Common Era BC, was for Pharaoh Khufu. And again, we've been talking, I think the oldest thing we talked about before this point was 300 BC, BCE. So this is 25, almost 2600 BCE, they created this incredible pyramid. And it was the tallest structure in the world for more than 4,300 years. So, what I want you guys to do now, I have two kind of these online games that I found. One is constructing a bionic arm. So an engineering activity that someone today might, be faced with. One is constructing the pyramids of Giza. And in both of these, you have to consider before you start, what do you have to consider? What are the things that you are going to be keeping in mind? And then they have more that comes up. So I want you guys to try both of these. I want you guys to try the bionic arm game first. This is just a game that pops up on your computer, like a little flash game. I do think you have to have flash on your computer. For me, it was working with both Safari and Google Chrome. So I hope for at least on those two web browsers, it should work fine as long as you have flash. So try the bionic arm first and spend about 5 minutes on that. It's okay if you don't finish, but at 2:15, I want you guys to switch to the pyramid game. And just be thinking about the questions that come up, the challenges that come up, and how they differ from each other. All right? Does anyone, okay, let me see. If anyone has questions, let me know. I want you guys to click that. I sent the links to you. I want you guys to click that first one, that first link, the bionic link first. And try that out. Press play the game. Okay, so this one requires Shockwave player. And then click the second link and do the pyramid builder game. The pyramid builder game has a lot of great questions in the beginning, and then you have to get to this part where you sail a ship, so that's a little bit off topic. But try that bionic arm game first, and then at about 5 or so minutes, I'll tell you to switch to the pyramid challenge. Does anyone have any questions on what they should be doing? All right, so we're going to start with this one here. Give it permission. You can update that if you need to, and if it's okay with your parents. And if you don't like the music, you can mute it down there. When you get to this point in the game, go ahead. You can either click on Learn to Build a Bionic Arm or I'm Ready to Build a Bionic Arm. It's actually going to be pretty similar to the questions you encounter. You can go ahead and say you're ready to build it and kind of be making those decisions. If you don't have Shockwave, you can go ahead and start the pyramid game, which I believe is a flash and not Shockwave. Yeah, well, I sent everyone a link to both games. It's under chat. The pyramid game is the second link. And it has been about 5 minutes, guys. I know you haven't been able to finish the Bionic Arm game, but if you want to try out the pyramid, go ahead and try that one out now. So again, guys, if I know you might not have finished the Bionic Arm game, but everybody should be trying out the Pyramid Builder game at this point. And just be thinking about the questions that you're considering in the design process. We're going to spend about 1 or 2 more minutes. Austin, I'm sorry that neither of those games are working for you. I can move along with the pyramid game if you want to watch that. Instructions aren't as important as first you have to consider the region. Click on them, you kind of get the pluses and minuses. Tomb Raiders. You have to select the angle. The materials you're going to build out of. You have to choose to orient it. Right, so there's these different steps. All right, guys, so we're going to bring it back. I've been showing kind of the thoughts that go into building this pyramid. If you guys couldn't have access to the game, let's jump back to the PowerPoint. So we have these questions. I want to know, what are you guys' thoughts on this? How do you guys think that technology has advanced or altered the design process? If we look back on this wheel, where we have, and you can type out an answer or raise your hand, kind of what we do today, it's a lot, we do a lot before we kind of build any sort of model or prototype, because there's a lot we can do with computers and math. So just think about this, and kind of this doesn't seem to be as large. What do you guys think has changed? Or what really stuck out to you when you were building the bionic arm? Elizabeth, that's such a great point. So Elizabeth says you can look up stuff easier, look stuff up easier. But that's this great point that you know, if you're in Egypt and another architect is in China, you guys cannot swap designs. It's people that have been able to kind of travel the world know the other architecture styles and are only able to kind of sketch them. You know, it's not this great swapping of ideas, whereas now all the great minds can kind of come together over technology. That was great, Elizabeth. Does anyone else have anything? You don't have to necessarily talk just about the design process, but just something you noticed when you were building the bionic arm or building the pyramid. I thought this part was really interesting, where here, in order to orient the pyramid so that it would be facing north, they used something like the sun, where the star, not necessarily the sun, would rise, and then where it would set in the east and the west, and use that to find north. They would bisect that angle. And that is a very, I mean, basic in some ways today, but advanced then idea of geometry and bisecting angles. And they used kind of just that star in the sky. They had that concept of east and west. Very interesting use of geometry without maybe knowing those formulas. Olivia, that's an excellent point. So a big thing with building this pyramid is that it was very difficult for them to get materials. When you were choosing whether or not you wanted to use limestone or granite, those were very difficult. They had to carry 2 million limestone limestone blocks when they actually built the Great Pyramid. Now, when you were choosing the material for your bionic arm, most of it just had to do with expense. And there are kind of the limitations that the materials could have, but it's not, there was a difference in what factored in with the materials. How heavy versus kind of how advanced or how technical it can be. Thanks, Elizabeth and Olivia. Does anyone else have something they noticed when they were playing either game that they wanted to bring up? And we did talk about this earlier, the idea that with math you're able to avoid some of those costs and some of those missteps when you're creating these models or prototypes, because you're able to plan ahead and have a better expectation of how things are going to affect, how stress and weight will affect your building. All right, and so how do you guys, what I want you guys to be thinking for Wednesday is how you would go about designing a pyramid now. How do you think that would change? If you guys had to build a pyramid, or not for Wednesday, though we will be doing something with it Wednesday, if you guys were to build a monument like a pyramid, that huge pyramid now, who could raise their hand and shout out something that they would do differently than when you were designing a pyramid in Egypt in the time of the pharaohs? I will give an example. Like Olivia said, I would not use limestone. Limestone is very heavy and very expensive. I might use steel, or I might use concrete. I mean, it wouldn't necessarily be as beautiful, but I'm saying for the reason that they had, which was protection. Those tombs, they wanted to protect the tombs of the pharaohs that lived there. It was a protective tool. So I might use a metal that would be maybe cheaper. Come on, guys. How would you design a pyramid now? Any other thoughts? Elizabeth says Legos. You know what? Legos are great for many things. It could have hurt. And a prosthetic back then, since we do only have 1 minute, so I am going to come back to this on Wednesday. I really want you guys to think about it. How would the design be different now? And that's something to really think about. Samuel says that you could use a compass to orient instead of stars, and that's really true. You can know exactly what north is, and you don't have to use those plumb lines, and you don't have to build that whole process. That process of building an actual wall and then marking where a certain star sets and falls, drawing those lines back and bisecting it exactly. That is not only incredibly difficult and not entirely accurate, though I'm sure they did a very accurate job of it, but it would be difficult to be accurate, but also very time consuming. They had to build that whole wall. So we could do that much quicker with a compass. Thanks, Sam. And I wanted to just briefly show you guys, this is actually a prosthetic toe during the time of the ancient Egyptians. And what's funny is that they made prosthetics very similarly to how they made prosthetics even 30 or 50 years ago. Not really much has changed in this technology until things like the advent of bionic arms were able to control this. So on Wednesday, we will hopefully be using Minecraft to build our own pyramids. So guys, I look forward to showing you that. And I would love to hear from you guys. I'm going to come back to this on Wednesday. I want to know more about what you could use, what technology you could use to go about designing the pyramids differently today. All right, guys, I'll see you on Wednesday. Have a good week.